Petrol engines have driven the Indian economy for decades. So if standard petrol already works, why is the government aggressively attempting to change the chemical makeup of the fuel in everyday vehicles? The answer comes down to raw exposure. To keep the country moving, India currently imports 89% of its crude oil from foreign nations. This chart shows the resulting financial drain. Every single year, roughly $137 billion leave the Indian economy to pay for these foreign crude imports. This level of reliance creates a severe geopolitical vulnerability. A single conflict in the Middle East or a blocked shipping lane can directly spike domestic fuel prices and crash the national currency, with the government entirely powerless to stop it. This is where ethanol enters the picture. Think of ethanol as the industrial cousin to drinking alcohol. Instead of being drilled from a desert thousands of miles away, it is a fuel grown directly from the earth. Globally, this fuel is produced by fermenting starches and sugars. While other nations might use maize or biomass, India's primary feedstocks are broken grains and vast quantities of sugarcane. By blending ethanol into the fuel supply, the macroeconomic equation reverses. Instead of sending billions of dollars outward to foreign oil producers, that wealth is redirected inward, funneling directly to domestic rural farmers and sugar mills. To understand the rollout, we have to look at the E-scale. E20, which is 20. The primary difference lies inside the fuel lines. A flex fuel vehicle is equipped with a specialized fuel composition sensor. As liquid travels from the tank, this sensor physically measures the exact ethanol to petrol ratio. That data is fed instantly into the engine control unit. Because ethanol has different combustion properties, the ECU dynamically adjusts the air-fuel ratio, injection volume, and ignition timing. This internal automation makes the transition viable. The driver doesn't need to perform any calculations at the pump. Whether they fill up with pure petrol, E20, or E85, the engine seamlessly optimizes itself. If domestic ethanol creates energy independence, the obvious engineering question is, why not mandate E100 or pure ethanol immediately? The barrier is chemical incompatibility. High concentrations of alcohol are corrosive to older components. Pumping pure ethanol into an unadapted engine will literally dissolve standard rubber seals, degrade gaskets, and rust metallic fuel lines over time. Beyond the vehicles, there is a massive logistical hurdle. India has over 88,000 national fuel stations. Handling pure ethanol requires completely separate underground storage tanks, specialized dispensers, and new blending facilities to prevent water absorption. Sweeping national transitions are governed by the hard limits of physical infrastructure and material science, not policy. Replacing millions of incompatible parts and overhauling thousands of stations takes years. This diagram illustrates the biggest consumer trade-off. Ethanol contains about 27% less energy per liter than regular petrol. This means the engine must burn more fuel to cover the same distance, resulting in a severe drop in mileage and shorter range per tank. There is also a systemic resource strain. Producing a single liter of E85 requires over 2,400 liters of water for the crops. During years of severe drought, prioritizing sugarcane for fuel directly threatens the land needed for food production. To bypass this problem, engineers are turning to second-generation or 2G ethanol. Instead of using edible grains or sugar, 2G facilities extract fuel entirely from agricultural waste, like rice husks and leftover sugarcane stalks. Processing this biomass hits two targets at once. It eliminates the conflict between food crops and fuel crops while preventing farmers from burning that waste in their fields, a practice that creates toxic winter smog across northern India. While the scale is massive, the strategy is proven. Following the Arab oil embargoes of the 1970s, oil prices tripled, forcing Brazil to pioneer the first nationwide transition to agricultural fuels. Today, sugarcane ethanol powers their economy. Over 84% of all new cars sold in Brazil are flex fuel vehicles. Similarly, the United States runs a massive secondary fuel market entirely on corn-based ethanol in the Midwest. These historical precedents prove that building a massive agricultural-based fuel economy isn't a theoretical exercise. With the right supply chain, it is physically and economically viable. For the everyday citizen, this rollout is an addition, not an immediate replacement. Existing legacy vehicles are entirely safe, as standard E20 petrol will remain widely available. Meanwhile, manufacturers are simply rolling out new models with flex fuel capability built in by default. To accelerate adoption without forcing millions to buy brand new cars, the industry proposes aftermarket conversion kits. These certified upgrades would modify the fuel lines and engine computers of millions of older vehicles, making them E85 compatible. These kits act as a bridge. They allow the government to push higher volumes of domestic ethanol into the market quickly, while ensuring the working class isn't economically stranded by the transition. This brings us to the elephant in the room. If the ultimate goal is zero oil dependency, why invest in combustion engines at all? Why not simply mandate a 100% switch to electric vehicles? For India, a total reliance on EVs presents a geopolitical trap. Transitioning entirely to battery power right now simply trades a dependency on Middle Eastern oil cartels for a dependency on Chinese battery manufacturing and raw material processing. E85 represents a third way. It is a domestically controlled energy source that relies entirely on resources generated within the country's own borders, processed by local labor. The push for E20, E85, and eventually E100 goes far beyond basic environmental targets. These blends are engineered tools designed to construct a firewall around the nation's economic sovereignty. The future of mobility won't be defined by a single universal technology. True energy security requires coexistence: electric vehicles dominating the cities, hydrogen powering heavy commercial transport, and domestically grown ethanol keeping the masses moving.